Welcome to Spaceverse, your portal to cosmic adventures. When scientists first saw images of Pluto, they discovered evidence of active geology, a revelation that was astonishing. A world so distant from the sun was expected to be a frozen, lifeless sphere, yet the photos revealed something far more complex. Pluto seemed to harbor secrets that challenged everything scientists thought they knew. Declassified images from the James Webb Space Telescope unveiled startling details beneath its icy exterior. What mysteries might be hidden beneath Pluto's frozen surface? One of the most groundbreaking discoveries is the possibility that Pluto's iconic heart-shaped glacier, Sputnik Planitia, may conceal a vast underground ocean. This glacier, composed of nitrogen ice and spanning over 1 million square miles, could be the icy crust above a reservoir of liquid water. If confirmed, it would mean Pluto has been defying expectations for billions of years. Alan Stern, lead investigator for NASA's New Horizons mission, considers this a vital clue in the search for life in the most unexpected places in the universe. Pluto's dynamic surface also tells a remarkable story. Towering mountain ranges made of solid water ice rise as high as 4 miles, comparable to Earth's tallest peaks. Even more intriguing, regions like Sputnik Planitia lack the craters typical of ancient celestial bodies bombarded by asteroids. Instead, the surface features strange polygonal patterns, suggesting a process called convection. Warmth from radioactive decay in Pluto's core may drive this movement, keeping the subsurface ocean from freezing completely. The surprises don't stop there. The enormous weight of Sputnik Planitia's ice has likely shifted Pluto's orientation, aligning the glacier with its largest moon, Charon. This alignment hints at a fascinating gravitational interplay between the two. Additionally, cracks and faults crisscross Pluto's surface, consistent with a crust flexing and shifting over an internal liquid layer. These discoveries raise an exciting possibility. Could life exist in the depths of Pluto's icy heart? The idea transforms our understanding of where life might thrive, pushing the boundaries of what we once thought possible. Pluto, far from being a frozen relic, is a dynamic world full of surprises, reshaping the quest for alien life. Physicist Brian Cox suggests that where there is water, life might not be far behind. The liquid state of Pluto's suspected ocean, shielded beneath a thick layer of ice, could protect any potential life forms from harsh radiation and extreme surface temperatures. While Cox remains cautious, he emphasizes that even discovering simple microbial life would be revolutionary. The goal isn't to find complex organisms, but to prove that life can thrive in conditions vastly different from Earth. However, confirming the existence of an ocean on Pluto is a significant challenge. The New Horizons spacecraft provided only a fleeting glimpse during its flyby, capturing detailed images of just 40% of Pluto's surface. Much of the dwarf planet remains unexplored, awaiting future missions to unlock its mysteries. Alan Stern and his team are already campaigning for a follow-up mission, the Pluto Orbiter, which could spend years conducting in-depth studies. Such a mission could finally determine whether a subsurface ocean exists and what it might mean for the potential of life. The possibility of a hidden ocean on Pluto extends beyond the dwarf planet itself, reshaping how scientists view the solar system. If an ocean can exist in one of the coldest, most distant places imaginable, it raises the question of where else water and possibly life might be found. Similar suspicions surround other icy worlds, such as Jupiter's moon Europa and Saturn's moon Enceladus, which also show evidence of subsurface oceans. These discoveries suggest that liquid water might be more common across the universe than previously imagined. Pluto's icy surface and potential hidden ocean raise questions about the possibility of life in extreme environments. But its origins might reveal even more. Some scientists propose that Pluto's ocean could be the result of a hot start, where the planet formed quickly through violent collisions. These impacts generated enough heat to create a liquid ocean, which has been maintained over billions of years by radioactive decay. This theory of a rapid and fiery beginning challenges earlier beliefs that Pluto formed slowly and remained cold and lifeless. If Pluto did indeed have a hot start, its ocean could have existed long enough for life to develop. Such findings force scientists to reconsider the boundaries of the habitable zone, extending the possibility of life far beyond the traditional limits once thought to define it. Pluto isn't unique in the Kuiper Belt. Other dwarf planets like Eris and Makemake may also conceal hidden oceans beneath their icy surfaces. These distant worlds open an exciting new frontier for exploration, offering clues to the origins of life in the universe. However, reaching and studying them is a monumental challenge. The New Horizons mission took nearly a decade to arrive at Pluto, and its data collection lasted only a few hours. A dedicated orbiter mission, like the proposed Pluto orbiter, could take over 27 years to complete and would demand significant technological advancements. From designing spacecraft capable of withstanding harsh conditions to developing long-lasting power sources, the obstacles are immense. The cost is another major consideration. A mission of this scale could exceed $3 billion. Despite these hurdles, many scientists believe the potential discoveries are worth the investment. Detailed studies of Pluto's ocean, geology, and atmosphere could revolutionize our understanding of the solar system and humanity's place within it. In the meantime, researchers continue to analyze data from New Horizons, uncovering new details about Pluto's complexity and dynamism. This small, distant world, once dismissed as a frozen rock, has proven to be full of surprises. Whether it's evidence of a subsurface ocean or ancient geological activity, Pluto reminds us that even the most overlooked places can hold incredible mysteries. The discovery of a potential ocean on Pluto extends far beyond the dwarf planet itself. It challenges our assumptions about where life can exist and encourages us to search for wonder in the most unexpected places. Even if any life forms on Pluto are incredibly simple, their discovery would redefine our understanding of habitability in the cosmos. Pluto, with its hidden potential, is no longer just a distant outpost in the Kuiper Belt. It's a source of wonder and a testament to the endless surprises the universe holds. While Pluto has already amazed us, the broader solar system holds even more secrets waiting to be revealed. From the moon to the edges of interstellar space, exploration has been a journey of discovery, reshaping how we view the universe and our role in it. This pursuit isn't just about studying planets and moons. It's about understanding our origins, exploring the unknown, and contemplating whether we share this cosmic playground with others. Humanity's enduring curiosity and the call of the stars drive us to push boundaries, daring us to reach ever further. Let's step beyond the textbooks and dig into what makes space exploration such a monumental journey. It all began in the 1950s and 60s, when the world's attention turned skyward, and the moon became the ultimate target, distant enough to inspire wonder, but close enough to be achievable. The Soviet Union led the charge, with Luna 2 crashing into the moon in 1959 as the first human-made object to reach another celestial body. Just a year later, Luna 3 captured the first images of the moon's far side, revealing a landscape no one had ever seen. The US wasn't about to be outdone. By 1969, NASA's Apollo program had made history by landing Neil Armstrong and Buzz Aldrin on the lunar surface, proving what humanity could accomplish with ambition and determination. But the story didn't end there. Attention shifted to Mars, a planet whose potential to harbor life has always captured imaginations. NASA's Mariner 4 gave us our first close-up look in 1965, revealing a barren, desert-like world, shattering hopes of lush alien landscapes. Still, the Viking missions in the 1970s pressed on, landing on the Martian surface to search for life, though they found little evidence. Fast forward to the 21st century, and Mars began to feel almost familiar thanks to rovers like Spirit, Opportunity, and Curiosity, which sent back stunning images and groundbreaking data. In 2021, Perseverance landed with a singular mission: collect samples and hold onto them until a future mission retrieves them. Meanwhile, Venus, a scorching world where lead melts and the atmosphere is toxic, also captured scientific attention. The Soviets' Venera 7 landed there in 1970, but survived only briefly in its extreme environment. Later, NASA's Magellan mission in the 1990s mapped Venus's volcanic surface using radar, offering insights into one of the most inhospitable places in the solar system. Then there are the gas giants Jupiter and Saturn, the showstoppers of the solar system. Pioneer 10 kicked things off in the 1970s, becoming the first spacecraft to visit Jupiter, followed by the iconic Voyager missions that delivered breathtaking images and groundbreaking discoveries. Galileo, which orbited Jupiter from 1995 to 2003, unveiled the wonders of its moons, from Io's erupting volcanoes to Europa's icy surface, which might conceal a hidden ocean. Saturn, with its mesmerizing rings, became a focus during the Cassini mission, which orbited the planet for over a decade. Cassini's Huygens probe even landed on Titan, revealing a moon with rivers and lakes made of methane, a world unlike any other. Moving further out, Uranus and Neptune, often overlooked, got their moment thanks to Voyager 2 in the 1980s. The mission revealed Uranus's peculiar magnetic field and Neptune's dynamic moon Triton, one of the coldest and most fascinating places in the solar system. These distant ice giants, though less explored, are full of mysteries waiting to be unraveled. Let's shift our focus to some of the smaller but equally fascinating players in our solar system. Asteroids and comets. These celestial objects hold the keys to our solar system's origins. In 2001, NASA's Near Shoemaker became the first spacecraft to land on an asteroid, touching down on Eros. Japan's Hayabusa missions followed, returning samples from Itokawa and Ryugu, while NASA's OSIRIS-REx mission grabbed material from Bennu, an asteroid with a remote chance of impacting Earth far in the future. Comets have also captured our imagination. The European Space Agency's Rosetta mission not only orbited a comet, but deployed the Philae lander onto its surface. Despite Philae bouncing into a shadowed area, the mission unveiled valuable insights about these icy wanderers. The Sun, however, remains the powerhouse of our solar system. NASA's Parker Solar Probe, launched in 2018, is venturing closer to the Sun than any spacecraft before, enduring intense heat to study solar winds and other phenomena that directly influence Earth. Meanwhile, the SOHO Observatory, a collaboration between NASA and ESA, has been monitoring the Sun since 1995, keeping us informed about solar storms and flares. Then there's the search for extraterrestrial life. Moons like Europa, orbiting Jupiter, are prime candidates. Beneath Europa's icy crust lies a hidden ocean that could potentially harbor life. NASA's Europa Clipper, set to launch soon, aims to study this intriguing moon. ESA's JUICE mission is already en route to explore Jupiter's other moons, including Ganymede, which may also have a subsurface ocean. These missions are about more than microbes. They're about answering the profound question: are we alone in the universe? Human space exploration is also ramping up. NASA's Artemis program aims to return astronauts to the moon, not just for short visits, but to establish a sustainable presence and use it as a springboard for Mars exploration. Meanwhile, SpaceX is spearheading plans for interplanetary travel, envisioning a future where humans become a multi-planetary species. Exploring the solar system is about more than collecting data. It's about pushing the limits of what's possible and envisioning a future beyond Earth. Every mission brings us closer to a reality where humanity thrives among the stars. Mars, in particular, has been a focal point for exploration, thanks to a fleet of robotic rovers that have traversed its dusty, rocky terrain for decades. These machines have unveiled Mars' story, its ancient landscapes, its evolution, and its potential for life. NASA's first Mars rover, Sojourner, made history in 1997 when it landed in Ares Vallis. Small, lightweight, and equipped with a camera and an X-ray spectrometer, Sojourner was designed as a technology test with an initial mission duration of 7 days. Instead, it operated for 83 days, sending back invaluable data and images that set the stage for future missions. In 2004, Spirit and Opportunity took the stage as part of NASA's Mars Exploration Rover program. Landing on opposite sides of the planet, these twin rovers exceeded all expectations. Spirit operated until 2010, while Opportunity defied the odds, remaining active until 2018. Both rovers uncovered evidence of Mars' wetter past, including minerals formed in water and signs of ancient lakes, game-changing discoveries that revealed Mars wasn't always the barren world we see today. These missions remind us that space exploration is a journey of persistence, curiosity, and endless possibilities. The question isn't whether we'll continue exploring, it's how far we're willing to go. Curiosity came next in 2012, raising the bar with its larger size and advanced scientific tools. It landed in Gale Crater, an area believed to have once held water. Since then, Curiosity has been uncovering evidence of Mars' watery history, including freshwater lakes and organic molecules, key ingredients for life, even if only microbial. These discoveries have completely reshaped our understanding of the red planet. Today, Curiosity is still hard at work, climbing slopes and drilling into rocks to reveal more of Mars' secrets. Then there's Perseverance, which touched down in 2021 at Jezero Crater. Its mission focuses on hunting for signs of ancient life and collecting rock samples that could eventually be returned to Earth for deeper analysis. Alongside it came Ingenuity, the tiny helicopter that made history as the first aircraft to fly on another planet, a groundbreaking achievement. Perseverance is currently exploring what was once a river delta, providing a clearer picture of Mars' watery past and the potential for life. But NASA isn't the only player on Mars. In 2021, China's space agency landed the Zhurong rover in Utopia Planitia, a massive plane. This milestone made China the second nation to successfully operate a rover on Mars. Zhurong has been studying the planet's surface and using ground-penetrating radar to explore below it. The data from this mission adds another layer to our understanding of Mars, allowing scientists to compare findings from different regions. Each rover mission builds on the successes of its predecessors, pushing the boundaries of what we know. From identifying water-related minerals to uncovering ancient lakes and hints of a once habitable environment, these robotic explorers are essential for answering the big questions about Mars. They're also paving the way for the day humans might set foot on the planet. Still, reaching Mars is no small feat. Every mission is a high-stakes gamble. The journey involves launching a rocket, traveling millions of miles through space, and landing on a planet with a thin atmosphere. Many attempts have failed, but when they succeed, the rewards are monumental. Each successful mission advances our understanding of Mars and showcases the incredible potential of human ingenuity. As Perseverance continues drilling and collecting samples, and Curiosity keeps trekking across the terrain, the story of Mars exploration is far from over. The next generation of rovers promises even greater discoveries. Mars isn't giving up its secrets easily, but these machines are steadily uncovering its mysteries, one dusty mile at a time. And beyond Mars, could Pluto's hidden ocean suggest life in unexpected places? Or does it hint at something even more profound? And that's it. Thanks for exploring with Spaceverse. Like, subscribe, and join us next time as we uncover more cosmic wonders. See you out there.